hear you. Okay. Yes. Yeah.
Miss Lorea, can you hear us now? Perfect. Nice. Then we're just getting ready. Perfectly. Thank you so much. We're just getting ready and then I think our moderator will take over.
Hello,
1, 2, 1, 2.
1, 2, 3.
Check, 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 check. Check, check, check.
Check, check, check. Hallo,
1, 2, 3, 4, 5. Ja, hallo. I'm an industry consultant, and I have the privilege of working with also with cement clients. I will now introduce my colleagues from in the panel. We'll start with Claude Lorea, who is in remote from London. She is an executive director for GCCA, which is the Global Cement and Concrete Association. For 3 years and a half, if I got it correctly. Before she was 14 years with Saint-Aubyn, which is the European Cement Association, including being Deputy Chief Executive, Industrial Policy Director, and Technical Director. So definitely an important voice to take in consideration in this panel. Next we have Stephan. He is a consultant of construction equipment and plant engineering with VDMA, which represents more than 3,400 German and European companies of the mechanical engineering industry. This industry employs around 4 million people in Europe and 1 million people in Germany alone. And finally, Juan Pablo Rincón is a researcher for the German Aerospace Center. He's a PhD candidate, and he has very interesting topics of research that we're going to talk about today, most particularly carbon capture, sequestration and utilization, calcium oxide looping cycle, and a few more things in renewable energies. If I got something wrong, please tell me. So, the idea today is to talk about cement industry, but the idea is to provide an overview of the innovation and try to my first question to the panel, and if you don't mind, I'll start with Claude in London, if possible, is why are cement emissions a problem, and what is the reason for the current 2030, 50 targets and current trajectory? Can you give us your point of view on the cement industry and the trajectory we are on right now?
Yeah, sure. Just maybe, I don't like fake news. So I'm actually, GCCA is based in London, but I'm speaking to you from Brussels, and my sincere apologies not to be with you. But Brussels is my home, and I'm actually still recovering from COVID. So I'm doing my best with my voice, but that's the reason I'm not with you. I was really still unable, and actually not allowed to travel and essential thing to tell our audience is that cement is the key ingredient of concrete. Cement is the glue of concrete, and concrete is this essential building material that you see all around you, that you see actually behind me as a background. This is a sustainable building material that has actually shaped our modern world, but that is also, if you look at the global trends today, that's going to shape the world of tomorrow, but that's also going to be essential for the green transition. Also, if you look at global mega trends and increased population, but also increased need for resilience, for school, for hospital, for infrastructure, for green infrastructure, for water sanitation, concrete is needed. Concrete is really an essential material. It's affordable, so it will also allow to build in an affordable way for the whole society. And then obviously cement is the glue of the concrete. To produce concrete, you bind sand, water, aggregates, gravels, and cement is the glue. And then we come to what you highlight, and cement indeed has a challenge. I don't like to say it's a problem, because I just explained to you that concrete is the solution for the world of tomorrow, but we have a challenge, and those are the emissions that are related to the production of cement. It is 7% of man-made CO2 emissions, not total greenhouse gas emission, but of man-made CO2 emissions. So it is important, indeed, but it also delivers a lot of savings. So when you talk to 7%, I also think you have to put it in comparison to all the savings delivered. I'm very, very proud to say that we have a plan at the GCCA. We are the Global Cement and Concrete Association. We represent 80% of the capacity, the cement production capacity in the world outside China. And also we have quite a few key players in China in our membership. And GCCA has released last October a roadmap to deliver net zero concrete by 2050. So a plan to eliminate what you call a problem. With 2050 targets, obviously, and that's the easy one to understand. It's net zero, no emissions anymore, and also intermediate target for 2030. Those targets are a real acceleration of the effort that the sector has already done so far. So also it's not that we have not done anything so far. The sector has already reduced by 20% since 1990, and we will reduce by a further 20% by 2030. So it's really doing this decade, or it's even not a decade anymore, what we have done over the last 30 years. So this is really an acceleration already, and then we will accelerate even further to go to net zero. So I think that's enough for the introduction. I'm sure you have other questions afterwards, and I want to leave space for the colleagues on the panel.
Thank you very much. I think I'll go straight to. Actually, I have a follow-up question to you. The 2030 target, before we move on to the colleagues. The 2030 target is 1/4 of reduction until 2030. And net zero is only 2050. And most of the people in the audience must be wondering, why does it take so long to go to net zero?
Yeah, well, we are already going now into more the details. Obviously, we have the levers that what I would call incremental levers, or the existing levers that we know. And I don't know if you want me to expand already on the levers, or we keep that for later. But also, we will need to require to use breakthrough technologies. Mainly carbon capture, use and storage, and actually we are now actively working this decade to be really ready to deploy that technology, and this is where innovation will come into play, and then be ready to deploy this one plant per week as from 2030. So it's just not possible to do this now, but it's really to be prepared. But our trajectory is absolutely in line with 1.5 degree and with all IE scenarios. So it's in line with what is required.
Thank you very much. Stephan, same question to you. You know, to complement a little bit what Claude said, from your perspective as a long-time worker in the industry, how do you see the difficulty of that emissions reduction?
Yeah, I fully agree with Claude. I think the problem is not the technology. The technology is there. The problem is the time we need to convert our cement plants into this new technology. Because, for example, if we look into oxy-fuel projects, there are some major modifications on, for example, the preheater tower necessary in the cement plants. And this is nothing you can do like this. So it would take time until all cement plants are modified. But I'm sure that we see much earlier the first results. So we will see already green cement in the near future. I think the first real oxy-fuel plant, it's still a test plant, but at least 500 tons per day, will be hopefully in operation in something like 20 months, 2 years. So, and then we will have first time in history a way to produce at least greener cement with the possibility to capture the more pure CO2 in such a cement plant. So this will help us. But again, some technologies still need to be more developed, more tested, but it will come. And so I'm a mechanical engineer, so I'm believing in technology. So therefore, I'm quite sure that there will be solutions. We will find our ways. It will take time, but we will make it. And we see it among our members. So as you said, we have 3,500 companies somehow working together, are connected and trying to fight against these challenges we have right now. And even for the normal machinery product, we have issues like carbon product footprint. So what we have heard already today, that in the future, whenever I make a machine, I have to show my customer how much CO2 this has consumed. So at the end, with all this, and then with knowing how much CO2 cement is consuming or steel is consuming, we'll get finally a full view about our emissions and where we can really make some savings. And I think we are on the way, but it takes time. And maybe we should have started earlier, but this is too late. Now we have to hurry up.
I also have a follow-up question for you, because you've mentioned green cement. So most of the people in the audience must be wondering, I never saw green cement before. What are you talking about? Perhaps it's a great opportunity for you to let us know a little bit about the different types of cement, perhaps relying on the SAM standard characteristics, and try to tell us a little bit what does the industry understand by green cement?
This is a very good question. For me, green cement is an easy way of saying that we have a cement which is which has produced less CO2 in the production. And there can be different ways to have it. We can, for example, calcine clay and mix it to the normal cement to have a similar, let me say, similar parameters we need to make our concrete at the end. Like we have, for example, today with fly ash, we can substitute cement with fly ash, and then we have, with less cement, a good quality concrete. But unfortunately, fly ash will not be there anymore once we shut down our coal-fired power plants. We can do the same with blast furnace slag. So basically what we need to find to make a more greener cement is capture of CO2, somehow storage, usage to get it out of the process, and substitute as much as possible of the normal Portland cement, or however we want to call it, with something we can produce with less CO2.
Great, thank you. And Juan Pablo, I think you know what the question is going to be, how difficult it is to make green cement, and you're currently a PhD candidate, so perhaps you can give us some insights on what you're working on and how we can get our hands on that possible alternative to green cement.
Yeah. Okay, sure. Yeah, just to complement about the targets, why do we need carbon capture in the cement industry? Yeah, here it is important that, or yeah, to clarify that from the 100% of the total CO2 emissions in a cement plant, about 60% are coming from the chemical reaction, from the thermal decomposition from limestone into calcium oxide and CO2. So we need to capture the CO2 in order to reduce the CO2 emissions in the cement plant. And that's the reason it will take a little bit longer. And how can we do that? Yeah, we have several technologies for carbon capture. There are already some technologies in the market, like for example, the use of amines to absorb the CO2. But of course, there are some pros and cons of each technology. Some cons of this technology or the use of amines are this is an energy-extensive process, especially to regenerate these amines. There are other alternatives like oxy-fuel combustion, but it will require also some modifications in the plant. But we have also some post-combustion technologies, like for example, calcium oxide looping cycle. It can be implemented inside the current process, but also as an additional unit of the cement plant. And there is where we are working in the institute, and calcium oxide looping cycle. This is based on the same chemical reaction, the thermal decomposition of limestone into calcium oxide and CO2. But this is a reversible reaction. So we can take the calcium oxide to absorb the CO2 from the flue gases of the cement plant and to get again limestone. So we can do a loop, and in each step, we can take the CO2 out of the process and send it to capturing or utilizing that. In our institute, in the Institute of Future Fuels, we are looking also how to utilize this CO2. And for example, if we have green hydrogen, we can produce synthetic fuels using the CO2 and the hydrogen. And also the other alternative, and talking about again the targets, in all the scenarios to reach the climate change goals, this technology of carbon capture and sequestration has to be considered. And we have already some demonstration plants in Norway, in the USA, and we have to scale up this process and to accelerate this process. But of course, for that, we need cooperation from industry, from government, and of course, from the research institutions.
Thank you. As you imagine, I also have another follow-up question. Please bear in mind that I'm an economist, so I'm at a disadvantage with engineers, so I have to ask these things. Why is it so difficult and expensive to do carbon capture, storage and usage? Why is it?
Okay, why it is difficult? Of course, we need policies and also understanding of the people about what is carbon capture, yeah? Because there is already this discussion, I don't want the CO2 below the ground, close to me, but of course there are appropriate sites for that. For example, empty oil fields or gas fields in the ground, and not everywhere we can storage CO2. So there are some specific sites around the world. And of course, if we want to capture the CO2 from all the cement plants, we will think how to transport the CO2 for those specific places. So it makes it expensive. But also depending on each technology, the process becomes expensive. For example, if we talk about oxy-fuel process, we need an air separation unit to produce oxygen for the combustion process, and this unit is really expensive. So it will increase the cost of the final product. And each technology has some disadvantages from the economical point of view.
I think that's a good segue to my next question, which is, it would go for Claude. What are the key solutions that the members of GCCA are working on that you can talk about? And how much of it is a technology, economical, policy, or regulatory issue from your point of view?
Yeah. So obviously, I think I already touched upon this. There are several levers. There are the known one, and I think we have already now through this conversation touched upon a few. But maybe it's good if I summarize, and to make it clear again for everyone and our audience who is probably not so acquainted with the process. So I explained cement is the key ingredient of concrete, and the key ingredient of cement is clinker. And it's the clinker that is produced in this kiln that we have already talked about. And the kiln requires a lot of energy. And there you have, as we have already heard now, the process emission and the combustion emission. So we obviously have, like any other industry, and that's how we have achieved the reduction we have achieved so far. We have efficiency measures in this production process that we know where we can do fuel switch. The cement industry has something unique, which is that we can actually replace fossil fuel by waste, which is resources from waste, and also biomass from waste. So that's one lever to reduce our process emissions. So it enhances further energy efficiency, but also fossil fuel substitution. Then we were explained we can try to reduce the amount of clinker that is used to produce the cement, which is then substituted by fly ash, slag, which are a byproduct from other industries, but also now ground limestone or calcine clay, and there is a lot of work on other clinker substitutes. That's what I call efficiencies in cement production. That substitution can also happen at the level of concrete, so we can take it further than cement. And this is also why whenever I will speak, I will not always stop at cement, as many people do. We need to look further down the value chain. And what our roadmap has identified is that we can actually do a lot of savings as well, or maybe not us, but the value chain. We can build more efficiently. We can design better the building. So there is also a way for the society to use less concrete. So it's about less clinker in cement, less cement in concrete, but also less concrete in production. And that's an important lever as well. Concrete recarbonate, so this nice reaction that we were just explaining actually works in the natural environment. So concrete also reabsorbs CO2 over its whole life, and this is a process we're also trying now to enhance at the end of life of concrete. So that's another lever that we have. Obviously, decarbonization of electricity is another important lever, because as any other industrial process, we are also an important electricity user. So efficiency in design, in construction, efficiency in contract production, efficiency in clinker production, savings in clinker production, decarbonization of electricity, recarbonation. But the rest is this carbon capture, use and storage technology, which we already aimed on. According to roadmap, it's 36% of the remaining of the emission reduction will come from CCUS. Now, to answer your question, I think that it's a mix of challenge down the road. Probably not so much technical, but there are challenges of having the right policies in place, and also collaboration with government, collaboration with the value chain. And that's actually why we have now further to roadmap launch local accelerators, moving from this global commitment now to local action. But I think we can elaborate on policies later. Maybe, if I may, on something that was said earlier, we said there is a few projects of CCUS. It's not a few. I'm struggling to keep up to date the map of CCUS projects. If you go on the GCCA website, you can see that there are now more than 30 projects in the industry. Different scale of development. And I was talking earlier about our targets. One of our 2030 targets is a commitment to have 10 full commercial scale CCUS plants by 2030. And we are very near already now with our members' commitment due to it. So I'm sure it will be more than that. So the industry is really actively working on getting this technology ready.
I'm actually happy that you went there, because my follow-up question to you is that rate of innovation is not really visible for most people. The players in the industry, they are really trying to innovate very, very fast, and they are actually investing quite sizable amounts of money into that innovation and decarbonizing. So my question to you is, given that we have a complicated situation in terms of fossil fuels, like natural gas, which really has an impact on prices and structure, on the operation structure of the players, how can, from your point of view, make the challenges of cement more visible to the public and also get their support in that decarbonizing challenge?
I'm not sure of the link to gas price, because I think I explained what our fuel strategy, I would say, is. But obviously energy price is an issue for all industry. I think that we are really doing huge effort now to talk to governments where we can at global level, and we are linking to initiatives like the Clean Energy Ministerial for CCUS or UNILO or ECD, the UNFCCC. So GCC is really talking at global level. And then, as I said, we are really working now at national level. We have a first set of roadmap accelerator, and we are also now looking at the second set of roadmap accelerator. And it's really trying to get the right policies in place. Now, I used to try to explain that to me there are three strands to pursue. Obviously, low carbon cement has to be made investable. So you need the policies in relation to carbon pricing. That's clearly a policy that is needed. Give a price to carbon. That's the way also to support the change. There is the wall, and I didn't comment, but I invite you to check our website. Yesterday, we had a webinar launching a report on low carbon procurement. I won't get into defining what a green cement or a green concrete is, but invite the people to check what we have released on what is green procurement. But we need to also have the demand for low carbon product to be stimulated. And then we need, and this is really essential, we need the whole infrastructure for the circular net zero economy. And that partially as well answer the question, why is it so difficult to implement CCUS? It's not only about the technology to capture the CO2 from the cement plant, even if that might be expensive. That's an easy bit technologically. But the whole question is, how do you connect all the cement plants in the world to a CO2 transport network? How do you bring that CO2 to the storage, and how do you manage the storage, or how do you create the hubs to link to other industries and create a CO2 value chain to have a proper use of the CO2? So I think, and this is really, really important, where there is a key role for government and public policy to manage this whole CO2 transport and storage infrastructure.
Great. Stephan, I'm going to give you two questions at the same time to complement what we just asked Claude. We heard you mention things like oxyfuel, and let's take it one step further. Oxyfuel, generation 1, generation 2. We talked about carbon capture. We talked also about using less clinker in cement, which would be a way to decarbonize. The two questions are, could you just give us a quick overview of, let's say, the innovation you see in the industry right now? And the second thing is, taking into consideration that you're working for VDMA, you're working with a lot of Mittelstand or mid-sized companies in Europe that also have quite a few challenges in terms of the investment required for those technologies.
Yeah, maybe the second question first. So yes, there is for sure a need for investment, no doubt. But what we can see is that investors are already looking to invest in more greener technology in companies who have the potential to supply such kind of products, helping somehow the conversion of the industry. So I think it will be from the investor side, maybe not such a big challenge, maybe, I don't know. But what is, I think, more important is that we are talking here about quite complex topics, issues, challenges, and there is really the point where all these smaller companies need to network and work together. And basically, among our members, we have ThyssenKrupp as well. And basically, it's important to get the big ones together with the small ones, and then try to improve and get this technology to new levels. And then another big issue is to integrate into this, let me say, existing society between small companies and big companies, all the new startups with a lot of ideas, but many times not with the access to the right contacts, to the people who are really interested and could then again integrate these ideas into the technology. So, and I think here's something where we need to improve as well. And we're trying this with a startup machine, where we have a kind of stage for startups to present themselves to our member companies and then get them connected. And yeah, so I think this is the way forward. And your first question was?
Was about the technologies, because we heard quite a few. Perhaps we can leave carbon capture to Juan Pablo to provide us a description of what type of infrastructure we are talking about. Yeah. Perhaps we can take an example like Northern Lights and explain a little bit how we could work, as you prefer. Take your preferred example. But my question to you is, we are talking about a set of technology like oxyfuel, which basically means that we have to change the way we currently make cement, or probably try to make cement with different proportions of clinker and other components in the final product. So it's like you have a long-term view on the industry, and you can see what is new lately, and that needs to be applied to a cement plant. So it would be great if you could give us like an overview of the change.
Overview is quite a bit difficult. So I think there are changes in such a new. Let me start with oxyfuel, with a new oxyfuel line. So, for example, the preheater will be smaller because we have less air volume. There must be somehow a separation in the clinker cooler, that we get one, let me say, from the recuperation area of the cooler, the oxyfuel air to the kiln, and so therefore we need some kind of separation. So there are some, let me say, technical challenges for the line as well. But again, there are, if I look from an engineer view on these challenges, then I think there are already solutions in the market. Not specifically developed for this technology, but there were some years ago, there was a flexible movable partition wall for a cooler, and I think such idea you could use perfectly today for this new technology. Or there was a radar system to measure the height of the clinker height on the static inlet of the cooler. So all these technologies, I think we can combine, and then it will be easier to get this new way of producing clinker into the market. So, and the same for calcined clay, for example. It's clear that calcined clay can substitute normal cement clinker, but the technology is there since many years. And basically it was not needed because cement was just cheap and nobody was taking care about emissions like today. But so we are not starting from zero, and this is giving me hope that we can accelerate.
Thank you. Juan Pablo, I would like to ask you a little bit specifically about carbon capture. You mentioned usage, and probably you also think about recycling it. You probably also think about the infrastructure, and you also mentioned oil fields and the need to use hydrocarbon subterranean deposits to do it. There are also other technical possibilities that we didn't talk about, but it would be great if you could give us an overview of the challenges in, bringing carbon capture to reality?
Okay. Yeah, here I have to say that I'm not an expert about carbon capture and storage. I'm more like in the technologies to capture CO2. Yeah, and here maybe we have to think. Of course, we need to storage CO2, but we have to think also about how to utilize this CO2 and to implement this CO2 in a circular economy. Yeah? For example, as I mentioned before, to create synthetic fuels, because in the future we will change to renewable energies, to hydrogen, but for the aviation, we will still to need to produce kerosene, and we can do it with synthetic fuels. Yeah? And here maybe I can share also with you about breakthrough technologies to capture CO2. And yeah, from our experience in our institute with this calcium oxide looping cycle. Yeah? For the calcium oxide looping cycle, we need energy to run the endothermal process from limestone into calcium oxide and CO2. And in our institute, we are providing this endothermal energy from concentrated solar power. Yeah? So with concentrated solar power, we can reach temperatures up to 2,500 degrees. And in our institute, we managed already to calcine cement raw mill at 900 degrees. In the current project where we are working now, which is called CEMSOL, we have also partners from the industry here in Germany. We are trying to produce this low CO2 emissions cement. And what we want to do there is to implement this solar calcium oxide looping cycle to capture the flue gases from the cement industry, but also to incorporate this production of lime into the cement process. So we won't calcine the clinker, we will calcine the limestone. Yeah, maybe that.
Thank you. Claude, what are the key roadblocks to decarbonize the industry? We're talking about cement, but you mentioned concrete, so perhaps best to bundle them together. What are the key roadblocks, in your point of view, to decarbonizing the industry?
If I may, because I think I touched upon this already when I presented, and I think we need a policy ask and we have the innovation. But if I may come in, I was trying, but it's hard when you're remote. I thought we had a hint that still this is an innovation, I think, panel. I would like to take a more global perspective. And at the GCCA, we are really aware of the key role of innovation. And this is one of my key roles as well at the GCCA, is to foster innovation in the sector. And I think innovation will obviously come from inside. And as we heard, there are things that we knew about and that needs to be developed. But we also strongly believe that we won't do this alone, and that innovation will come from the outside as well. And we have two key innovation initiatives at the GCCA. One is a global research network that does slightly more long-term research that is needed to still understand better some of the issues that really ties together the best and brightest minds on earth in relation to cement and concrete, both from the academic and the industry world and equipment suppliers. And I think that that's an amazing and that's a unique initiative that illustrates collaboration, which is to me one of the roadblock as well, is to foster collaboration. But the other initiative that has been super successful this year is that GCCA has launched the Open Innovation Challenge. And it came to my mind when I heard the colleagues on the panel speaking about startups and what are now really the new ideas. And we have really gone to submit to the world two challenges. One was related to carbon capture and storage. The other one was related to carbon use. So we are really at the core of what we are discussing today. And we sourced 100 startups. And months ago, we announced that from those 100 startups sourced, our members have now signed 6 consortium agreements and taking now those startups to a demo day. And I think really this illustrates the role of innovation and what are the ideas out there and how we can collaborate. And then the next key issue will be financing. And that's one thing we haven't touched upon today. You are an economist, you said, but we will also need to make sure that we get the financing mechanism in place to support all those pilots and all those startups and projects.
Same question to you. The key roadblocks that you see in terms of innovation and decarbonizing the industry, from your point of view?
For me, I think one roadblock we have right now is to get all this new kind of concrete into the standard, because I think this is still a process. It's in place, it's under preparation, but it takes time. And as long as it's not in the standards, no architect, no building company will use this new materials. So therefore, I think it's a must that we find a way to integrate this new binding material, this new concretes, whatever, into our standards. And it's not only the binders itself, as Claude said. We have a lot of innovation on, for example, of carbon reinforcement in concrete. We know that we can use less concrete if we use carbon fiber instead of steel reinforcement. But all this needs again to be integrated in the standards. And some other countries are, let me say, a little bit faster in applying these technologies to the market, like Italy or the Netherlands. And I think we need to get a higher speed there just to have it and to save already now concrete, even if it's gray concrete, but we can save already today a nice amount of cement or concrete by using these new technologies.
Actually, a small follow-up question there, because people might not be aware that not only you have a European standard for cement, like the SEM, which is actually being in the process of being updated, and some players in the industry complain that it takes too long. Why, and also, furthermore, why each country in Europe tends to have their own standard to complement the SEM? So why are there so many standards, and why do they take so long to be updated?
Well, I think, we are Europe, but we have still, let me say, a long tradition of our own standards. And I'm personally involved not in the concrete standard, but for example in the standardization of tools on site. And this is then done by a SEN technical committee, and then you have to meet with the experts, and then you modify your standards, and this is just taking time. And then you have some control loops by the European Commissioning, where some HAS consultants have to check what you are doing. And at the end, maybe a small modification takes 2 years. So, and this is fact. But on the other hand, I think all our standardization system is based on an agreement. So all parties are involved, and they are working on the standard. So therefore, most likely, if you want to keep it, that everybody agrees on the new standard, then it just takes time.
Good. Well, Juan Pablo, it's, the question is going to be, what are the roadblocks that you perceive? Is this a technological issue? Is like a question of resources? From your point of view, how can we accelerate this the decarbonization?
Okay, I would say that we need, just as Claude mentioned, to accelerate the innovation process, we need more or a higher number of projects focused on that specific purpose, to decarbonize the cement industry. Because as a research institute, when we try to get funding, we have to participate in calls for big topics. But if there are specific calls or more calls about that topic, we will have a higher number of projects working on that direction, and it will accelerate the innovation process. Of course, we need also a stronger communication between industry, research institutions, and government. From our experience in the first projects, it was not so easy to bring on board the industry, yeah, because we have to, of course, to convince them about the idea. But in the last projects, the industry is calling us, okay, how can we participate? How can we take part on that project? And this is really interesting, but of course, as I mentioned before, we need like a higher number of projects to accelerate this innovation process.
We're actually 10 minutes away from ending the session, so I'll invite anyone who has questions to actually direct them to FCA. Well, I can provide 3 questions, but I would like to do a quick lightning round with the panel participants, which is if I could grant you 3 wishes in the innovation of cement and concrete, what would you ask for, Claude? As you are in Brussels, perhaps it's it comes to your heart, some of the wishes. You mentioned carbon pricing, so it definitely seems like a hot topic.
Well, I mean, 3 wishes. It depends. I don't want to comment on European policies. This is not the purpose. That was my past job, not now. So I don't want to link my wishes to European or to Brussels politics. I think that the first wish is partnership, is partnership, and then we will achieve this only by working together, and maybe there it means that we need value chain partners to collaborate with us. It means we need policymakers, governments, but not only in Brussels, all over the world to collaborate with us. We need innovators, we need the financial institutions to collaborate and really have the right tool in place. Obviously also collaboration in our industry. So my wish would really be around collaboration and everyone involvement in this journey. Our industry is committed, but we will not make it alone.
Good, same question to you. Stephan?
I will support fully Claude. I think we can make this only in partnership, getting everybody involved. And I think at the end we need to transport this message to the consumers as well. So I dream of maybe having in the future a bag of cement in front of me where I have a label like we have for the meat today in our supermarkets. But this maybe will help to improve the acceptance of all this, what we have to do.
Juan Pablo, I'm going to ask you for a very quick wish, and then perhaps give the audience the opportunity to ask 2 or 3 very short questions, please.
Yeah, same answer as my partners here. But I would maybe also add that my wish will be also like to communicate in an easier way to the public why it is important to decarbonize cement and why it is not so easy like with other industrial processes, I think.
So thanks a lot for this very interesting panel. I had a very short question. Given the numbers, the size of the CO2 production involved or explicitly linked to the cement industry, do you see in the future that cement industry will still produce concrete, or maybe will transform to some kind of industry that has concrete as one of the products and then an array of carbon-containing products? Or
I'll give perhaps this question to Claude. What type of alternatives? Which is a bit of a mean question, considering that you are in the association. What type of alternatives?
I mean, it's not a thing. We certainly are. Sustainability is our DNA, and we don't want to miss a transformation that we have to take. I would say that probably the concrete and the cement of tomorrow are not going to be exactly the same as the one of today, but I don't know any other material and raw material that is abundant in the quantities that are needed to produce. Maybe that's is closing the loop. One fact that we didn't mention is that I said it's affordable, but actually concrete is an artificial stone. It's made of limestone, which is one of the most abundant material on Earth. And this is our main raw material. And I still believe that the concrete of tomorrow are going to be made of limestone or limestone based, but net zero.
Yeah, maybe I can just add one point, because for me, it's the cement. For me, a world without cement, I cannot imagine. So there will be cement always, but already today, the cement factory, they are contributing in a way that they are burning waste we cannot burn elsewhere, like dioxin. So we have this high temperatures there. So even for this, most likely, we need cement plant in the future to get rid of the stuff. And even for countries where the recycling is maybe not so advanced, burning all this plastic waste could help communities. So it's maybe not the top, but helpful for the time being.
So they are frantically giving me the sign. Please ask the second question and the third. Please.
So, Marta, working for Bologna, Brussels-based NGO. My question is on CCU. So when you mention CCU as a, climate technology and using CO2 coming from processes to produce fuels, it's true. I mean, you're reducing emissions or abating emissions in the cement industry, but you're just transferring your emissions to another sector, and those emissions will, like that CO2, will be vented anyway. So, how do we, from a, that's not closing the loop. That CO2 will go in the atmosphere anyway. So how can we consider, transferring the emissions to another sector as like an abatement technology?
Okay, maybe I can take this question. Yeah, the idea, of course, you are right. We are transferring the emissions from the cement industry to the fuels. But in the case of of carbon capture, also the idea or the next step will be to capture the CO2 from the air atmosphere. And so we can do it. But of course, we need to develop first in a really mature level these technologies to capture CO2. Yep.
And I would also like to complement a little bit. It's not my role, but I'll do it anyway. In carbon capture and storage, you actually store it. So it's the reverse process of extracting hydrocarbons. Now, that raises other questions that we don't have the time to touch, but definitely transferring emissions is not really an option.
That's why my question was on CCU analysis.
Yes.
Do you see a client group, an off-taker group that is willing to pay a green premium for green cement? And how large would that be?
Let me just add to the question, especially if we have alternatives like cheap cement from third-party producers. And perhaps Claude and Stephan, I would like you to address this question. Like, are people willing to pay for green cement?
I mean, that's clearly what I was hinting to with our webinar yesterday, which I really invite you to watch because it's a big topic. But I really see, as I said, the pull and push policy. So we need this carbon pricing, and we need to create this demand for low carbon product. We are, as the GCC, involved in many in our green procurement initiative, and yes, we start to see this green premium idea coming up. You obviously need to define what is green cement, but this is where the change has to happen as well. Yes.
Yeah, I think we have no choice than paying more money for the cement in the future, because if we want to somehow to produce it with less CO2, there is no choice. And I think that there will be, or there have to be, some measurements to protect the cement industry producing green cement against imports not produced under this green level, let me say. So therefore, I think building a house will be will be more expensive in the future.
So I'll take this opportunity to close the session. It was a real pleasure. I'm supposed to sum up, but I think with your final 3 wishes, like you were very clear on the need to actually have innovation as a sort of cooperative effort. And it's not only on the industry side, but also on everyone's side to understand these issues a little bit better, and some of us even to participate in the cement and concrete industry. I remember a few years ago when it was the dream of many of us to build bridges. But right now construction materials is not the sexiest industry. And perhaps given the size of the problem, it would be great that some of the great minds in innovation would contribute to the effort of decarbonizing this industry. And on that note, I would love to thank the organization ARC for giving us this opportunity. I know that we only had 1 hour. We would have a lot more to talk about. I would like to thank the panelists for making my job so easy. It was a real pleasure counting on all of you, and speed recovery to you, Claude, in Brussels.
Thank you.
And thank you very much to all of you, and thank you to the audience.